Assalamualaikum. I'm Ahmad, Haikal, and this is brother Khairul, and this is brother Ariff. We are from group 5 from ECON 430T class, and today I'm going to present to you about our second assignment, Open Economy Gauss model. So in this model, we try to see how can three exogenous changes occur in this open economy. So firstly, in this model, we said there will be two industry. We assume two industry, agriculture and industry. After that, we define our variable from Leon's income, consumption, production, capital demand, labor demand, lump sum transfer back to household, price level, labor supply, capital price, local demand for domestic products, import, export, import prices, work prices, composite price, and domestic prices. After we list down and define all the variable, we then define our parameters. Firstly, income, consumption, production, capital demand, labor demand, price level, labor supply, capital supply, labor price, capital price, local demand for domestic product, import, export, import and work prices, composite prices, domestic price, scale parameter, share of capital to production, share of goods I in total budget, Amirin coefficient for imported product, Amirin coefficient for local product, local tariff, elasticity of the substitution between import and local products, elasticity of export demand, scale parameters for the export demand, foreign tariff and custom duties, and lastly tax rate. And then we list down all the equation that we will use in this model. Firstly, the supply function, labor demand function, capital demand function, income equation, government revenue equation, demand of local goods, demand of imported goods, demand of goods, the consumption price, import price, the export demand, good equilibrium, capital equilibrium, labor equilibrium, trade balance, and lastly domestic price. After that, we show how the structure of each of the variable the equation. Firstly, this is the supply demand, these are the labor demand equation, these are the capital demand equation, income, government revenue function equation, how it look like, government demand, G demand, and all of these are the equation. You can see we have listed down all that we have mentioned before. And then we move on to the calibration. These are what we assume in our equilibrium in our model. PO is for all industry is 1, PC is 1, PWM is 1, L for agriculture, labor demand for agriculture is 10, labor demand for industry is 2, K for agriculture is 2, K for in industry is 10, X for agriculture is 2, X for industry is 8, M import for agriculture is 5, M for industry is 5, and then sigma for sigma is 5, sigma X is 3, and DDX for agriculture is 0.2, DDX for industry is 0.2 also, and both DD for both industry is 1, and for each of the of labor and capital, the W will be equal to Z1, and also these are all the calibration that we create. A lot of it. I don't want to explain all of it in detail. So here are the calibration process, the side, and then we move on to the most important, the crucial part, which are initialization. We assume that income times L will equate to income naught. C capital times labor demand for every industry will lead to CO for all industry. Basically, all of these are the endogenous. All of these are in the endogenous variable, because it has time with L. L here indicate endogenous variable, which are a variable that we want to see the effect of changes of exogenous variable. And because of this, these are the endogenous variable. So what we want to change is this, which are labor supply, capital supply, and work price. Before we go this, we want to check whether the model is feasible or not. We look at the feasibility numbers here, which Here. If we look at this, we can see that the number of infeasibility is 4.295, which are power of E minus 10, which are actually near to 0. It indicates that this model is feasible to use. Okay, because of this, we can use it to check the changes of fx, which are exogenous variable, affecting all the endogenous variable. So for my first part, I will try to explain what if the work price change to by 15%, increase by 15%. This maybe occur during, for example, oil price shock, like in the 1980, where the price fluctuate, for example. So this may affect some of the endogenous variable. So we solve by the way, we also assume dd is equal to 0, and also ddx is based on the calibration value that we mentioned before. That's why we have star here. So we run this, and then the result will be given here, but this look messy, right? So we move to Excel. Here are the result. We can see that K for agriculture and industry gives a different result. For K, the changes is decreasing, but for industry, the changes is increasing by 2. For labor, for L, agri also decrease while industry increase. For income, WL and WL it also decreasing here, but the WK increasing. P for both increase, for both industry increase. C for both industry decreases. Y for agri decrease, Y for industry increases. PM price for imports for both decreases, while PC for agriculture decrease, although PC for industry increases. X for both agriculture and industry increases. M for both also increases. PD for agriculture and industry increases. And lastly, demand for agriculture, D for agriculture and D for industry decreases. We can see here. So those all of these changes actually in line with the theory. We can see that actually how can I say this? To start with, I can when work price increases, we can see that actually import price rise, it lead to higher input costs, and it dampens sector that use many import. Also producer prices will rise if those sector can pass through cost increases or benefit from better term of trade. And thirdly, we can say that it can lead to resource reallocation factor flows toward the sector with the bigger relative price gain. Fourthly, we can say that by theory, output Y should fall in the sector hit hard by cost push and rise in the one with stronger price gain. 5, we can say that import should fall. Costlier import lead to lower quantity demanded. And lastly, we can say that by theory, export should rise, better work price, which means higher export supply. So based on the list of the result, actually they assume there is a mismatch from the theory itself. Firstly, we can see that PM fell instead of rising. What happened actually? We updated PM, but didn't reshout the PM margin directly. Our price for import equation still use the old baseline. So actually price of import actually dropped from 1.2 to 1.15. So actually we should fix this by actually shout also PM or recompute PM via changing the equation after raising the work price. So that is the first one. Secondly, is about the import increase instead of fell, because since the price for import fell, imported input become cheaper, so firm imported more. So that's why it actually not in line with the theory itself. Also PC. Okay, PC here is also not following the PC, which are the composite consumer prices, also not in line with the theory. PC agriculture decreases slightly, and by PC for industry increases but barely. Why? Because we can say that actually import price lower and consumption volume drop disproportionately. The ratio end up slightly below 1. A more standard Aminter aggregator with ECES share would keep PC between PD and PM and always move it upward when both input cost more. Tapi what actually those align perfectly. We can say that P and PD increase with a larger gain in the more input intensive industry. Resource shift K and L flow that correctly toward industry. Output fall in agriculture, rises in industry. Export jump from both sector on better wood prices. Factor price sign which are WL and WL which are quite ambiguous, while WK rises are reasonable given our production structure. So these are the impact of our of when the work price increases by 15%. So for the cycle changes.
So right now, as for me, basically I would like to do the changes for the capital supply, but whereby I want to choose a situation. As we know, sometimes Malaysia does have injection for the investment, right? So normally, if we do have the injection for the investment, it will raise our capital, basically the capital for the industry. So therefore, I choose to raise the capital supply for around 20%, assuming that the other thing remain the same. So let's see this. So we're going to simulate regarding the changes that I'm going to make. For the capital supply, we increase with the 20%, 1.2, we times with 1.2. Then after we run, we managed to get the result, right? So here's the result. As you can see here, most of the variables in our model does have changes due to the capital supply increment of 20%. The only thing that remain fixed or remain the same is only regarding for the labor supply. So let's see the effects or the changes that happen in all of the variables. So the first thing we can see here, our capital demand for industry increased by 24%. However, our capital demand for agriculture decreased by 1.9, and then our WK, our capital price, dropped by 11.5%. You can see here our WK, and then our production for the industry increased by 23%. However, for our agriculture, it decreased by 3.8%. 3.8%. So as for income, you can see here, income does have decreased by 11.2% due to the increase in the capital supply. And then our WL, the wage also fell by 9.3%. You can see here. And then our labor demand, whereby regarding for the labor demand for the industry increased by 21%, and for the agriculture it does have decreased by 4.2%. Regarding the price, you can see here, price for the agriculture as well as for the price for industry, both of it have decreased in their value by 9.6% as well as for the 11.1%. And then for the export, you can see here for the exports we have increase in both of agriculture and also industry, because we know our production does have increased for industry actually. So export also increased. You can see here the export for the industry increased by 42%, and for the agriculture is lower than the industry by 35%. It does have the increase but lower than the industry. And then for the general prices here, you can see the decrease in the agriculture, and the import for the agriculture and the industry also, both of it have the increase in the imports for agriculture and also industry. And for the domestic demand, you can see here for the agriculture and the industry, it does have decrease in the local demand. If you can see here, most of the variable here, it does align with economic theory. However, there's a third part from the variable that we can question regarding about it. So the first thing regarding about the income, where income INC here, you can see income fall. However, we just have an increment in the production for the industry, because we know for the capital supply, normally it does affect the industry sector more rather than the agriculture, because agriculture is more to the labor intensive method. However, this kind of mismatch in the economic theory does not really mean that we violate totally the economic theory, because we know capital price and wage rate both fall. The capital price and the wage rate both decrease, right? So significantly due to the increased supply and relative abundance of capital. So even though output increase, the value earned from it returns to the capital and labor drops more steeply. This causes total factor payments income to decline. In CGE models, normally this is realistic if markets are perfectly competitive. More supply push prices and returns down. So this income falls is not happen because of the production fall, but because the return to the factors, the capital and labor shrink. So this shows how consistent the CGE models behave, which is not a violation actually. And then the second one, regarding about domestic demand. Domestic demand, we can see it does have decreased, right? It's supposed when we have some injection for the capital supply investment, supposedly the demand should increase because we managed to increase our production, right? So but it is reasonable because it may feel odd that the local demand drops, but this is not also a violation because imports are now cheaper or more attractive, so consumers substitute because of now due to the injection itself. Now our products for the local demands is more, we can say that it is more, can be competitive with the imported product. So that's how people are substitute or attractive with the imported goods, and the lower income reduces overall consumption despite more goods being available. So this matches consumer optimization behavior in open economy models. So that's how we can question some part of the variable that seems matchmaking with the economic theory. So I guess that's for the second changes that we made from the capital supply by increasing it by 20%. So we have one more changes for our model. So we go to next one, Brother Ariff.
So for the last changes is the labor supply. For the labor supply, we have decided to put a shock which is increase 50% in labor supply. So a situation that may suit this phenomena is the post-COVID labor recovery situation, where we can see a lot of people are getting back their jobs, so they are increased in the labor supply. So for our simulation, we need to multiply with 1.15 and then run it. So for the result, this is the result. Wait. So basically, we can see that the labor usage rises significantly in both sectors, in agriculture and industry, for about 14.42% and 17.89%. And as for the output, we can see both increase. In agriculture, we can see increment of 11 and 42%, and in industry, we can see 3.2%. However, there are price decline due to higher supply pressure, which is in the wage of labor. Wage of labor, we can see decline of 17.61%, and in the wage or in the capital return, we can see reduce about 3.35%. And next, we can see the price of goods here. So the price of good fall about 15.39% for the agriculture, and as for the industrial, we can see also a fall, which is 5.89%. And let's move to the export for both section. So in agriculture, we can see increase quite a lot, 65.11%, and in the industry, we can see 19.98%, almost 20% increase. And lastly, let's move to the income, which is INC. INC is decreased by 13.21%. Alright. So the real income fall because even though more people are working in the economy, the total income goes down. So this phenomena happen because wages fall when there are more workers available, and the return from using capitals like machine and equipment from the plantation also drop a little. So this situation shows an important short-term effect, which is when labor supply increases, it helps produce more goods, but it doesn't always mean that people or the economy will earn more money or be better off right away. But it's only happen on a short-term situation. And the next phenomena is we can see that higher income in some household and lower import prices. So even though the real income is decreases, and at the same time we can see the import also increase because of when the price of imported good drops by PM 16.67%. This one, those goods become cheaper for consumers. So this encourages people to buy more of them because they get more value for their money. At the same time, even though total income in the economy falls, some household, especially that those that now have jobs due to increase in labor demands, they may see income rise in their family or in their career lah. So with more money in their hands and cheaper imported goods available, they are more likely to increase their spending, especially on the imported good. So even if the overall income is lower, the combination of cheaper prices and better job for some household leads to higher demand in the imported good. Okay, boss. So in a nutshell, from all the three shocks that we have applied in our model, in our simulation, it still have some violation to the economics theory, but it is out of our limit, out of our ability to control it, because it may have come from the formula that is not changed, or if we change any formula, that will occur an error in the game itself. So it still have a minor violation to the theory, but all the result is actually logically still can be accepted in the real world situation, especially if you want to make a policy out of it. And I think this will be the end of the video. Sorry if it is too lengthy, and a big thank you for Dr. Zakaria for teaching us this semester.
I hope this model is the best, not the best, but it be good, and the result can be accepted despite maybe some changes that's supposed to be made. But we use it as the best, we made it as the best that we can for this particular model that we choose, and the changes as well for the shocks. I guess
that's all for us. Thank you for watching. Bye.